The next type of function we're going to discuss is the quadratic function. The important part of a quadratic function is the highest exponent is 2. Y equals x squared is the parent function for a quadratic, and it's the parent function because there are no translations. A few more examples of quadratic functions could be y equals 3x to the second minus 3x plus 4. Y equals negative 1/2 x to the second plus 5. All three of these are quadratic functions because their highest exponent is 2. An example of an equation that is not quadratic would be y equals 4x to the third plus 2x squared minus 5. And the reason this is not quadratic is because the highest exponent is 3. Another way to tell if a function is quadratic is based on the general shape. And the general shape of a quadratic is a parabola. And a parabola is simply a U-shaped graph. The important part of this parabola is what we call the vertex. And in this case, since it's opening up, that vertex is the minimum value. The third way to tell if a function is quadratic is by looking at the table of values. So what we will do is first find the differences of our y values by doing 1 minus 4, 0 minus 1, 1 minus 0, and then 4 minus 1. And you can see those values are all different. So we will continue to the second difference. Negative 1 minus negative 3 is 2. 1 minus negative 1 is also 2. 3 minus 1 is also 2. Since those values are all equal, this function given in the table is a quadratic function. So if the second differences are the same, then it is quadratic. Next up is whether or where the graph is increasing or decreasing. When reading a graph, you do want to read it from left to right. So if we're looking at where is the graph increasing, that means where are the y values getting larger from left to right. So if you look at the parabola opening up, where the values are getting larger would be on the right-hand side. And if you look at the parabola opening down, where are the y values getting larger, that would be on the left-hand side. Then to look and see where it's decreasing. So decreasing means our y values are getting smaller. And that would be on the left-hand side of the parabola that's opening up. And then over here would be on the right-hand side. Those values are getting smaller. So when we're talking about increasing or decreasing, where that's happening, we are looking at the y values. Where are the y values getting larger? Where are they getting smaller? Next up is where the parabola has a max or min. The maximum or minimum is always located at the vertex. And if the parabola is opening up, that vertex is a minimum because that's the lowest y value on that graph. And if you look at the parabola that's opening down, the vertex is the highest y value. So we call that the maximum. Next up is rate of change. Rate of change is not constant. And that's because it's increasing or decreasing at different rates. Is the graph of a parabola symmetric? And our answer is yes. It is symmetric over the vertical line that runs through the vertex. So if you draw a dotted line through the vertex, this line is called the axis of symmetry. And what it means is if we were to fold the paper along that dotted line, all the points on the left of the parabola would match up with all the points on the right. So the parabola is always symmetric over the axis of symmetry, and just remember the axis of symmetry is a vertical line that runs through the vertex. And the final part of a quadratic function that we're going to talk about today is domain and range. So we're going to look at the parent graph, y equals x squared. Remember, domain deals with x values, our input values, and range deals with our y values, which are the output values. So when you're looking at the input values, you can put any number in for x, negative or positive or 0. So for our domain here will be all real numbers. So that just means all x values will work. And when we're looking at the range, notice here at your graph, all of the points are above the x-axis or at 0. So with our range, we don't want to include any negative values because there's no points down here. So our range will be all y's greater than or equal to 0.